Hello, everyone, and welcome to a new episode of Debugging on Live. It's been a
We are
while.
still alive.
So, hello, Marc. Good morning.
Hello, Matteo. Yeah, good morning for a surprising new episode out of nowhere.
Yeah, we promised you an episode the last time, but we got sidetracked, let's say, from other things. So, but now we are back on track.
It was last summer, if I remember correctly. So we had like a longer hiatus.
Let's say it's been a few busy months.
Oh yeah, that it has been a few busy months indeed. Yeah.
Today we are back to talk about a topic that we never touched before in this show, right, Marc? Which is AI. Surprise, right?
Surprise.
Even if this time, in the previous episodes, we talk about AI often more from let's say, philosophical perspective. So understanding more about the current status of AI. So we talked about LLMs, generative AI, and so on. Today we will try to be more concrete, talking about a concrete implementation of integrating AI into applications. And we're going to do that with a framework created by Microsoft called the Semantic Kernel, which is a way to integrate AI, especially more complex AI workflows, into your applications. You might be familiar with the concept of orchestrating AI workflows, because there's another tool in the market which is very, very popular and that Marc knows well, which is LangChain. What is a semantic kernel? Is it a competitor of LangChain? Yes and no, meaning that first, it's not really a competitor because in Microsoft we have full support for LangChain in our platform, and we use LangChain as well, probably in our internal services somehow. So it's not really a competitor for us, and it's not a competitor also because they are targeting two different audiences. LangChain is the standard for Python developers. Semantic Kernel instead is more tailored for .NET and C# developers. Yes, we have Python support in Semantic Kernel, but I think the real value of Semantic Kernel is when you use it for .NET, because if you are a .NET developer, you can't just take LangChain and use it in your .NET application.
I would like to add that LangChain also supports everyone's darling JavaScript.
Yeah, I'm aware of that. But I will.
I just leave it at this.
This saying that Semantic Kernel supports also Java. So
does it? No.
Yeah. There's a Java version of Semantic Kernel as well. Yeah.
Oh no, really? I wasn't
Java,
aware.
Python, and I know that the JavaScript support was in the works. I don't know the current status, but Java and Python are supported. Even if I have to just to set the expectation, since probably also the team behind Semantic Kernel has realized that the real value is for C# developers. C# version is always one step ahead. For example, they recently released the 1.0 version, and the first bits to have the new stuff was the C# code.
It's similar with LangChain as well, right? So Python is kind of like the first-class citizen. JavaScript is, there is JavaScript. It's also supported, but it's usually like the implementation used to be a bit slower of new features and so on and so forth. And all the examples on the documentation are definitely in Python. So
yeah. All right, so let's jump right into the topic. And why we have this concept of AI orchestrations. In the end, if you think about services like OpenAI or Azure OpenAI, it's not rocket science. To use them, you have REST APIs, you call them, you send the prompt, you send the configuration, and you get back a response. However, the reality is that when you start to build a real application, you have to do more than that. Sometimes you have to manage multiple services and models, each of them with different APIs. You need to have a chat experience, so you have to manage context and history. A lot of times when you build your own custom AI application rather than using something already existing, is because you need to implement a way to work with your data. And so you step into the retrieval augmented generation world. Or sometimes you have to perform complex tasks that require to chain multiple operations. So all things that doing them manually, just calling the REST APIs, might be a bit challenging. So this is why an orchestrator like Semantic Kernel or LangChain can help to really make this easier because they provide a series of endpoints of extension methods to connect to the most popular AI services like OpenAI, Azure OpenAI, or recently also Hugging Face models. And then they expose a series of methods and functions that are standards. So if you want to switch at some point from OpenAI to Azure OpenAI, you just change the registration of the service and you don't touch anything else in your code. And then they are called orchestrators also because they have this a concept of AI orchestrations, which is very powerful, and we will see this in a bit. But basically, the idea is that you can tell to Semantic Kernel which are the services that you are available. You define the ask that you want to achieve, and you let the Semantic Kernel figure out what to use and how to use these services to satisfy your ask. So let's jump. I won't go through. I have quite a good chunk of demos and articles on this topic. I won't go through all of them because otherwise we will make a 3 hours video. But let me show you the basic configuration. So how you set up a basic project. So in this case, it's a .NET application. It's a console application. And what I did was adding the package Microsoft.semantic kernel from NuGet. And here you can see the basic configuration. So Semantic Kernel rotates, is built around the concept of kernel, which is the one that you use to perform all the operations against AI. And as you can see, setting up the kernel to use a specific service is a matter of using an extension method. So in this case, I'm using Azure OpenAI. I want to use the text generation. So I want to generate text. So I use the add Azure OpenAI chat completion method, and I provide the information that the Azure portal gives me. So in this case, the deployment name, the endpoint, and the API key. If I want to use another type of model, for example, text embedding or text to image, I can just use another one of the flavors of the extension method. And if instead of the Azure OpenAI, I want to use the public OpenAI service, I have the equivalent for OpenAI. So if at some point I need to switch one service from another, I can just do that without touching the rest of the code. And then here you can see an example of writing a prompt, so submitting a request to a large language model. This is a very basic example. I don't think that because you are reading this, you will go and suddenly run to implement Semantic Kernel everywhere. But it shows you one neat feature, which is the templating support inside the Semantic Kernel. So I can define a function, a prompt. I can set up a placeholder, and then instead of having 10 different variations of the same prompt just because I need to change the input, I simply supply a kernel arguments object with the input, with the placeholder, with the values for the placeholders. And then I call my prompt, my function, and I execute it. So if you take a look at the execution of this code, in this case, I have a prompt in which I provide a sentence in input, and I want to turn this sentence into a business mail. Nothing rocket science. But in this case, I'm supplying the sentence that I want to convert into a mail into a prompt with a prompt template. And as you can see, I'm getting the mail as a response. I can also fine tune the prompt, so I can set things like the temperature, the tokens. And I also have support, and this is pretty neat as well, for streaming responses. So instead of getting the whole response out of the box, I can use prompt streaming, which means that you will get the effect that you see, for example, when you use ChatGPT, that the response is generated on the fly, step by step, instead of having the one-shot response. So this is pretty basic, but it shows you some of the advantages of switching to semantic kernel. However, this is really basic. I don't think, again, that you're going to throw everything and switch to semantic kernel just for that. Things become more interesting when you start to introduce the concept of plugins. So you can have in your applications a series of plugins that can extend the capabilities of semantic kernel. And there are two big families of plugins. You have prompt functions, which is basically a way to take a prompt and instead of hard coding it into the code, storing that in a dedicated file, in a dedicated folder, so that you can reuse them more easily. And the second one are native functions, which instead are plugins that are running into that are using native code. So this means that they can, for example, integrate with third-party services, perform operations with native APIs, and so on. These native plugins can be exposed also as OpenAI plugins. So the idea is that if you have already built a plugin for OpenAI, you can reuse the same into your applications. So I won't go through the entire demo for the sake of time, but I will show you just, for example, that the scenario here, so the prompt to generate a professional mail, I can also move it into a plugin. So in this case, in this project, I have a folder called plugins with a mail plugin and a function called write business mail. This function is made by a text file with the same exact prompt you have seen in code and a config file with the configuration and of the prompt. Recently,
quick question.
Yeah.
How would you provide few shot examples? Is it possible
to provide samples on how to use this one?
No, well, so for example, when I build prompts or when I use the prompt templates for LangChain, I can also provide few shot examples, which make the few shot technical examples that help improve the answer. Would this be part of just the regular text, or do I have like a different template just as in LangChain? Because I think you have the few shot message template, or what is the name, to improve, like to make it aware that there is like an array of examples now as input to be expected. Is that possible in Semantic Kernel?
No, I don't know. I never seen something like that in Semantic Kernel. Okay. We just provide them as text information, but very
okay. So you would just write them down, kind of like you would in the chat. Okay, got it.
Yeah, right. And since one new features that they added in 1.0, which I'm sure that it will be loved, by every developer in the world is that now the prompts can be stored also with YAML files. So if you want, you can have a YAML to keep everything in a single file.
Mm-hmm.
But regardless of your choice, you can see that with this approach, you don't need anymore to hard code the prompt into your application, but you can import a plugin from, in this case, from the directory, and then you can call the plugin directly without having to write the prompt here. You just supply the input parameter. So it's a very good way to have a catalog of prompts that you can store and reuse.
Do you have to, this is like a more specific question, do you have to provide the name of the plugin that you import, or can you just tell it like use all plugins in that particular directory? Because if you're like building larger projects and reuse modules, you might just want to provide a complete directory.
No, you have to provide the name of the plugin, but a plugin can have multiple functions. So in this case, you can see that my mail plugin has only one function called write business mail, but I could have here 10 different functions, and when I import the plugin, automatically they will be all imported. All of 10 will be imported.
I see. Okay, so for a bigger, like for a bigger chain with multiple plugins, no, that would just mean a single plugin and modularized by adding just many functions like a mail, I don't know, REST retrieval and whatnot. Okay, got it. Mm-hmm.
Yeah, correct. And then this is another example instead. This is an example instead of a native plugin. So in this case, with a native plugin, the big difference is that it's code. It's not just a prompt, but it's code. So for example, here we have a plugin that is able to interact with a third-party service. In this case, there's a platform called Data USA to get statistical information about the United States. I have a couple of functions to retrieve the number of population from the given a specific year. And this is a REST API call. So I can't do that just with a prompt. I need to use the full HTTP client and the full REST APIs. And the difference is that when you use this approach, you have to import the plugin using this entry point, which is import plugin for type. And then also in this case, if you want, you can call the plugin directly by supplying the input arguments.
Can you go back to the plugin, please?
Yes, of course.
The response is the response. Okay, so you do have a contract, like the United States response is some kind of contract. So the semantic kernel is aware of the expected okay, JSON.
No, it's actually just a mode, just a set of information. No, it doesn't need to have a specific contract. As long as you return a text, it's
I see.
A specific contract.
Okay.
However, these plugins you saw isolated, they are interesting, but there isn't much value. For example, this one, why should I build a plugin? I can just call this API directly and that's it. The real value comes when you start to introduce the concept of orchestrating our flow. So instead of using these plugins in a manual way, so calling them in the right order, knowing how to call them, the right parameters to set, you can use the concept of function calling or planners to basically define a task, defines a series of functions, and then let the model figure out how to call them. Originally, Semantic Kernel supported this through a feature called Planner, which is basically an object that was making multiple LLM calls to generate a plan using the information that it has and the available plugins, and then execute the plan. After the release of 1.0, instead, the Semantic Kernel team changed a little bit things because OpenAI came up with a feature, a built-in feature in the latest version of their models to support this scenario, which is called function calling. So I will skip some slides, but basically, when you do function calling, you can send to a model like GPT-4 or GPT-3.5 Turbo. You can send not only the request of the user, like the prompt. So in this case, what is the weather like in Boston? But you can specify also a series of functions, a series of plugins. You can think of them like plugins that you have available to perform a task. And in this case, what is the weather like in Boston? It's a type of question that out of the box, the LLM is not able to answer, because LLM by default are not connected to internet. They are trained with a data set that is frozen in time, so they are not able to give you a current information like what's the weather like in a city. So we are telling to the LLM, hey, you know that I have a function called get current weather that you can call with to get the weather, and the function works this way. You have to provide in input a location and the unit type. The LLM will generate for you a function calling, so it will tell you, hey, you need to call the get current weather with this parameter already formatted in the right way. Then it's up to you as a developer to go and call the API using this information. So the LLM won't do that for you. You have to go, for example, in this case, go to the weather APIs, call them with the payload provided by the LLM, get a response from the APIs, and then call again the model by supplying the information that you got from the current weather API. So in this case, you can see that we are sending another request to OpenAI, but we are not including only the question of the user, what is the weather like, but also the response that we got from the function. Since now the LLM has all the information that it needs, it's able to generate a response. So it's nice, it's cool, but as you can see, it requires a lot of manual work, because it was up to us to call the weather APIs. With Semantic Kernel, instead, we can load the plugins out of the box as functions, and most of all, we can let Semantic Kernel call them on our behalf. So we don't need to manually call them, but everything will be done automatically. So here is an example. So combining the information you have seen before. So here, for example, I want to write, the request is to write a paragraph to share the population of the United States in 2015. Make sure to specify how many people among the population identify themselves as male and female. Don't share approximation, please share the exact numbers. This is a type of request that, in order to be executed, requires calling 2 times the plugin you have seen before. One to get 3 times, actually. One to get the total population, one to get the male population, and one to get the female population. So instead of doing this manually, you can do it manually if you want. I don't know why someone would want to do that, mainly for debugging purposes. But if you want, in Semantic Kernel, you can replicate what I just shared with you with the OpenAI APIs. So calling manually all the functions. But the simplest way is to do this automatically. So you can just enable this. Let me. So in this case, you just set that you want to auto-invoke all the kernel functions, and you send the prompt. Automatically, if we put, we have loaded, of course, the United States plugin before, and now Semantic Kernel will go into the kernel to identify which plugins are available, and it will generate a plan for us. So if I run this application, you will see that if everything goes well, in a few seconds, you will see that Copilot will generate a text. Copilot, I'm working so much with Copilot that I call everything Copilot. Semantic Kernel is going to generate for us this paragraph by calling my plugin, by combining the LLM with my plugin to get the information about the United States. If you want to make sure that this is indeed what happened, this is the reason why you might want to enable the manual calling. So if I uncomment the code that you have seen before, so we are enabling now the manual calling, and if I put a breakpoint here, so we are doing the same. The only difference is that we are now sending the request to OpenAI, and we are getting the list of functions that OpenAI has identified that it needs to call. If we let this run, we can see that inside function calls we have 3 items. So Semantic Kernel has automatically figured out that in order to satisfy my ask, it needs to call the get population function of the United States plugin with parameter year 2015, and then 2 times the get population by gender function of the United States plugin, once with year 2005 gender male and once with year 2005 gender female. So from this starting prompt, it was able to automatically extract all the input parameters, all the output parameters. It figured out the right order. So as we see, we are asking about the population, male and female. So it called them in this order and so on. We can see that these are the 3 JSON responses that we have received from our API, from our plugin. And even if it's a JSON response, the LLM was smart enough to figure out how to use this data. So we get not a JSON response, but we get a full paragraph in natural language.
Makes sense. Although I think if the manual approach makes really sense if you need to fine-tune the order, because I don't know if you can give the automatic involve, like the auto invoke kernel function, if you can provide the order of the execution. I think it figures it out by itself, and maybe sometimes it's not the optimal way or the way you need to call this. So I guess there is a reason, but most of the time, I guess you're right. It's just easier, right?
Yeah, I would say that the main reason is scenarios like this. In most of the cases, one of the values is that it should be able to figure out the right order. But if it doesn't, you can fine-tune that. And the other reason is debugging. So if something goes wrong or you don't get the expected result, with the other approach, you don't get many information to understand what happened. Here, instead, you can see exactly the functions that were executed and which ones have been retrieved. So it's much more powerful. And these are a couple of custom plugins you have seen, but if you want to do more complex stuff, the Semantic Kernel team has created also a set of plugins that you can use in applications. For example, in the repository, and we will share the link later, you will find also a graph plugin, which is a plugin created by the product group to interact with the Microsoft Graph. So, for example, here I have an application that I'm able to use to ask what is my next meeting, and by pulling information from my calendar is able to do that. Or the other example is the Bing plugin. There's also a Google plugin, if you prefer, which is about getting fresh information from internet. So the example I have here is that you have this application about asking about what is the semantic kernel from Microsoft. And if I remember well this demo, what happens is that so if I don't import the plugin. I didn't test the demo before the recording, so let's see if something breaks. But if you run this without the plugin, so now I'm executing the plan, but the semantic kernel doesn't have any plugin loaded inside, so it's going to send the request directly to the LLM. And as you can see, it's telling you that as of my last update in 2023, semantic kernel doesn't refer to a specific product or technology released by Microsoft, because when the model was cut, semantic kernel wasn't a thing yet. This semantic kernel started to be released towards the second part of the last year. If instead I add the Bing plugin, so I let semantic kernel understand that it can use this plugin to generate a response. Now it's going to use this plugin combined with the LLM, and the outcome you should see is that instead we will get a response that should be more up to date. So as you can see, it's taking a little bit longer because it's not just connecting to the LLM, but it's also making a web search in the middle. Come on.
It's searching the web.
It's searching the entire web. Yeah.
On its 56K modem.
Exactly. Yeah. It's running because I see the memory decreasing. So it's doing something, but I don't know exactly what.
No, there it is. It's
okay,
dead, Jim.
Yeah. Let's try again. I imported the plugin, right? Yes.
So it's live. It's not pre-rendered or whatnot. It's live.
Yeah, not really the expected result, but it's live. No, I don't. But my bad. This must be set to auto invoke kernel functions. Otherwise, it's waiting for me to call the functions on its behalf. So he's right. It's not its fault. So
yeah, and there it goes. Okay.
Yeah, as you can see now, we are getting a better response because now we are able to connect to internet and pull data from internet.
Okay.
There's one. I don't know. I mean, we have another topic to cover around semantic kernel.
Shall we do a second episode, or want to push it in
another episode, or because
I would say let's stop with a cliffhanger because and hopefully we have a memory next time to remember.
No, that's a good idea because we have another topic which is pretty important for us when you work with LLMs, but I don't want to rush it. So let's save it for the next time. But just let's give you an idea of what we're going to talk about, so you'll follow also the next episode. So we mentioned in the beginning that one of the challenges that you have to manage when you are building a custom application is implementing in the proper way retrieval augmented generation, because a lot of times when you are building a custom experience and not using a default one, it's because you have to use an LLM to query your own data. In the past one of the reasons why I was so busy in the past months is that I was working on Microsoft 365 Copilot. That's an example of an AI implementation which uses retrieval augmented generation, because with Copilot you can ask questions about your organizational data. So of course there are scenarios instead in which you might want to build your custom experience or your custom data. So we have from Semantic Kernel team we have a few helpers to do that with a component called kernel memory that greatly simplifies the whole process of taking content, generating embeddings which are needed for doing a semantic search, asking questions about custom content. These are all things that we will see in a more detailed way next time.
Okay, sounds great. And I guess next time I will also probably chime in with a few other, I have a few more questions because, as Matteo said in the beginning, I'm coming more from the LangChain side and know a few features and tricks from LangChain. And for me, semantic kernel is, well, it is for me something that is actually worth looking at with the release of 1.0 because it has been a bit interesting, wild from it previously. And I have some more questions that I would like to have answered. So I would
Sounds
say
like a plan.
Sounds like a plan. And I probably have a few. I will open my Azure ML instance because I have lots of LangChain examples. So if there's something that I want to or need to show, I can just use.
Well, if you are brave, I have also some crazy examples running. For example, I was able to make a semantic kernel working with open source LLMs running on my local machine.
Nice. This sounds great because that is really easy on or rather easy on LangChain, and yeah. You might want to promote your website where you put on all
so I
your
don't
thoughts.
like self-promotion, but I mean, it makes sense since we are discussing about this topic. So if you want to go deeper into everything that we discussed so far, so I have recently revamped my blog. So I launched a new blog called the Developers Cantina, and I started with semantic kernel because it was the technology I was working more in the past weeks. So basically, everything that I covered so far very quickly with the demos and the explanation is available in more details on my blog. So for every main feature of semantic kernel, function calling, planners, plugins, you will find a post. And all these posts, sorry?
Turn it to dark mode. Thank you.
And all these posts, you will find the links over there as well, are also connected to my GitHub repo called Semantic Kernel Demos, where you will find
You actually pinned it on the main page. It's on the bottom right.
All right, it's here. So here you will find my repo called the Semantic Kernel Demos, where you will find all the code that I was sharing with you during the presentation. So that the website is www.developerscantina.com. Actually, let me use the banner feature of our streaming platform to showcase the URL so that
Bam.
I see I'm multitasking, I'm showing demos, I'm doing a lot of stuff at the same time.
Great presenter.
Oh, thank you.
Like and subscribe.
Subscribe to our YouTube channel with so that we can reach at least 10 subscribers. No, just joking. Probably we have more, like 15. But whatever. I mean, we're doing this because we like it, not because we are aiming.
Exactly. Only if but once we hit, I don't know, like 10,000 subscribers, we will put in advertising.
Yeah, of course. I mean,
no. No. Yeah.
All right. So stay tuned for the next episode. I promise that we promise that we won't wait so much. I mean, the content is already there, so we just need to schedule a new recording. So we promise you that it will be in the next 1 or 2 weeks, no later than that. So stay tuned, and thank you for following us so far.
Yes, I follow you. Yeah. So thank you, everyone. Stay tuned for more semantic kernel. Matteo is actually doing a session about semantic kernel in the next few weeks.
Yeah,
I'm doing also a session about semantic kernel in the next few weeks, but I'm coming more from the LangChain side. So basically, I do like comparing or running both in parallel and entertain the crowd. So I guess
the downside of my session is that it's for a local event here in Italy. So unless you speak Italian, it's not a good fit for you. So, but yeah, I'm doing that next Tuesday.
Okay, so mine is on the 30th here in Berlin. I'm doing events. There's a AI and metaverse event for
blockchain.
No crypto bros.
Throwing buzzwords here and there. So.
Yeah, quantum. What else do we have? No, seriously, it's just AI. We also have Chris Hellman at our session.
Cool.
Yeah, he used to work for us, still for us. So I still know him, so we invited him. But yeah, so local events are great. Visit your local events, meet with the community, visit Matteo's event, throw your underwear at the stage.
Please, no, that's okay. That's okay. Just ask questions.
Okay, then you just use like, I don't know, bags full of money or something.
That's more appreciated. Yeah, that's more appreciated.
Perfect. All right.
See you soon. Bye-bye.
Bye.